Welcome. Today we're gonna have a look at the challenge 391. What we have, it's a Pokemon dataset. We talk about you have different types of Pokemon. Usually it's a type 1 and a type 2. Some Pokemon has only one single attribute. Some may have two attributes. So the question is looking for you want to consider is how many combination of attributes you have. Among those combinations, which particular combination you do not have. We have 800 in the list. We'll go through the list. So, for example, you never have a Pokemon has a bug and a dark, or vice versa. And the condition is we don't worry about unique combinations. So the reverse order treated the same. It's big questions of combinations. We're gonna do with Alteryx, try to see how we can handle these things. Now, because of this challenge, we only care about the Pokemon and the attribute. We don't actually worry about other metrics. We can take a job of everything else. Other things, be careful. Also doing it. For example, Venusaur, you have Mega Evolutions. They have the same ID for the Pokemon, which is almost caught me out. So we want to keep both the Pokemon ID and Pokemon name. That's it. Let's give it a start. So you're going to have two branch. One is to first figure out how many combinations you have. The way to create a list, you want to group your type 1, type 2 together. So we're going to pivot our data. So it's Y to long format. Let's drag in. We keep only the metrics we're interested. So what we're going to do is we're going to group by ID, group by name. For the type, deselect everything else. Type 1, type 2, that should be able to pivot the data. Once it's pivoted, we can do a summarize to get it now. We do have some null value, so we do not actually interested. We can group that later, drop them. So we can summarize first, then we can drop values. Group by. We know we're gonna have some kind of null value, so we can actually filter the null values. So after group by, we're looking for is not null. What do you expect? You should expect you should have 18 distinct type. So we have 19. If we do the filter, we get 18 rows of data. So that's 18 distinct type of data. That's fun. Then the next thing you want to almost do a self join. So the type must join with the type itself. Because we're looking for a particular, the order doesn't matter. So it's a combination. Another way to handle it better rather than match a string, I think it's probably easier to match by some kind of number. So let's sort. We sort ascending. So they are sorted alphabetically. It doesn't matter you do ascending, descending, it's the same idea. Once it's sorted, we're going to drag record ID. So we know that smaller the record, it's further ahead in the sorting order. We can see how we can use this one to handle both the repeating type and to handle the order of combinations. Next, we're going to do is append. Append behaves, the way I look at it, append is almost behave like a self-join. So you want to cross join, you want to almost explode your table. Be careful with the selection. So we have 18 rows here. If you do not change default, you'll get a warning on it. We allow all append, so we don't mind the 18. Record ID, we'll keep both as it is. Let's run it. So the input is 18, so we're going to do cross join of 18 by 18. We're going to pass, I think it's 300 something. So we should, 324 rows. Then let's filter out the rows we are interested. Because we have ID, it makes it much easier to sort. So for example, the left-hand side, we want our record ID to be strictly less than the source record ID. Because in that case, we'll drop the repeating join. Everything else will be after. If we go to it in the dark, which is 2, so it will skip the repeating and it will skip the bug that combination, which we already did in the first batch. With that, we'll see we're going to have distinct amount of combinations after. So overall, we have dropped from 324 rows to 153 rows. So everything here should be distinct. All the darks go to 2. Then we have a descending amount. You can see the last one, steel. There's only one more after steel. That's the water. Okay, that's a benchmark list. We can use this list to compare with our Pokemon. Now, if we look at the Pokemon, we notice the type 1, type 2. We need to be able to almost re-sort it. We want to sort alphabetically. So the whoever comes first will be type 1, the other will be type 2. The way to sort it, we're gonna do my favor to group by sort tile tool. Let's see how we're gonna set up the tile tool. What we're gonna do is you have multiple choice to do different things. So let's actually say we're gonna do unique. I don't think it's unique. Equal records. Because if you have 800, so type 1, type 2, you should be actually 400 tiles. You can do 400 or another way to do it is 2, because it's every 1, 2, 1, 2. It does. The reason I choose equal records because it gives you the option to do a sort. If we click on input, what we want to do, we want to group by the ID, we want to group by the name. We want to sort by our value. So you want to sort things alphabetically. Let's have a look at the answer. Each of those. Yeah. Okay. For example, this one. Type 1, type 2, type 1, type 2. Yeah, that's fine. Maybe this. Yeah, those guys. Maybe are better examples. So the first one, you can see. No, so whatever that is. Your type 1 is normal. Your type 2 is null. So it's a single type Pokemon. But once we sorted it, now it's automatically bumped to the first option. So that's why it's 1 tower number. Then normal will be tower 2. The one below, Dodo. That one is normal, but alphabetically sorting, flying is F is ahead. And so we create a tower number 1, 2 instead. So it goes to the order we prefer. Once that's done, we can pivot our data points. It's white, it's a long format, so we want to go from long to white. We're going to handle the null value later as well. Still group by Pokemon ID, the name 1 column we want. Type 2, we don't name 2, we don't care. The header should be tile number, so we want column 1, column 2. The value goes from the value. We should be able to concatenate. Everything else, don't worry about it. Can keep the default setting. Let's check our stuff. Okay, good. So hopefully you can manage check all the combinations 1 and 2. They are sorted alphabetically. So in that case, it fit into the list we created on top. We don't care about Pokemons with only single type, so we can filter those out because now is always filtered first, and all Pokemon has at least 1 attribute, so you shouldn't have column 1, column 2 both now. So they filter the blank space so it's not empty. Good. So we reduced to about 400 Pokemons with 2 different types. The next is a choice. Because this list is not necessarily distinct, you can drag a unique on it. Or you can just do a join to filter. Give 2 choice. So 1, you can literally do the join filter. The left hand side is the top part because that's all the possible combination for the 2 types. Then the right is the extra list we have. Because we sorted, so we know our record ID 1 sorry, value one. Value, source value should match up to column one and column two. We don't care about everything else. It's only care about which row is selected, which row is not selected. If we click on the left hand side, so the left join, the left outer join, so those are the particular combination that does not exist in our Pokemon list. So we have 38 rows, and you can see that's what 38 rows. If we take those guys, do look at sort. We want to sort by value one first, then we sort value source value. So we should be able to see all the things is, so with all the bug type. So that should be 6 rows for the bug type, 6 rows for bug type, 3 for dark, 2 for dragon, 3 for dark, 2 for dragon. That is the intended results. So that is how we're gonna do for the challenge 391. It's to do with the sorting of your items, particular about how do you handle permutation with the things. Usually my strategy is literally rearrange your list. If you encode your list into record ID, it makes sorting a lot easier as well. Okay, and that's for this challenge. Thanks for watching.